Okay, so it's January 11th. Today's our first Android class. We kind of spent the first part of class today just getting a bit of background, going over the course. So we fired up Android Studio, and this is typically what we get. So it prompts us to create a new project. If we've already had a previous project open, it will default to opening that last project. So some weeks we'll build on top of what we've done the previous weeks, but for the first few weeks, because we're just kind of getting our feet wet, we'll build a whole bunch of mini solutions. So I'll just maybe call this one layouts, because that's what we'll play around with. We don't need Kotlin support for now, and it'll ask you for some kind of domain. So I've just put in my own domain that I have, and then it adds this. We can modify this, but there's our package where all our code will get bundled eventually if we want to deploy to the Play Store. Actually, I'll just go up a little bit here. Oops. Sorry. I'll just create a projects folder inside my folder for the course. So here's where we get the screen asking, what do we want? So which API version? So I have API, I have both 23 and 28 installed. If you just have 28 installed, it's going to tell you that your app will run on probably something significantly less than 62%. What percentage do you get if you target 28? Less than 1? So the other thing you can do, if you don't want it on 28, since we're here at the college, if you want, you can choose an older version, like say 23 is a pretty common one.
That's the one I recommended, right? I think.
Yep. So you can choose, yeah, Will Ice Cream Sandwich is a way back to API 14. 23 is probably fairly safe. And if you don't have that version, it'll prompt you to install, and then it will download about a gig's worth of stuff. Again, better to do that here, faster to do it here. You can pick whatever version you like. I'm going to maybe target API 23, give me approximately 2/3 of devices. And notice also, we talked about, we listed all the different types of devices Android can run on. It does ask us, basically, what kind of device are we? So we're basically going to be picking phone and tablet. So there's some different interfaces, obviously, for working with. It's not all one. So we have to choose when we're creating the project. We can't create a project that's going to run on Android Auto and on your phone. It's going to be one or the other. We've got to choose that. And if you go to this help me choose, it'll kind of gives you this, right, which is useful. And one of the other nice things is that this actually describes the API version. So we can see, for example, hey, if we want to access something on the device, you know, what does this version of the API support? Okay, so if we want to go back to ice cream sandwich, yeah, well, there's not much, right? You can interact with the calendar, basically. Is about it. So this is pretty useful little tool. I'm going to pick Marshmallow. So we get this screen. So Android has some terminology that's a little bit weird, in my opinion. So for example, they use the terminology activity to refer to what we would in more common language call forms or screens. These are referred to as activities in Android. So we have templates. We can have an absolutely blank project. And the two that are the most common are empty activity, where we at least have a back button, or the basic activity, which does also give us a settings menu, and this little button here, which is known as a floating action button. So it's some kind of primary action. We can reposition, restyle that button. So we'll mostly work with these two. When you guys are building your assignments, you're allowed to use these templates to do some of the design work and kind of setting up the infrastructure. So once you talk to your client group, you'll figure out, you know, hey, are we going to design this all from scratch, or can we sort of use a template to do some of this stuff, automate some of the UI work? So there's other templates here, Google Maps, for example. There's a login activity, which is neat, so it will pre-build a login screen for you. Okay, we'll manually do one probably next week. They've got a master detail, so this might be another one that you maybe want to experiment with. But it already has a template with a list. When you click it, it jumps you to a detail view showing you that item. Okay. We've got side nav. So for now, we'll pick an empty activity. By default, the first activity is called main activity. We'll want to generate a layout file with our layout name, and we will make it backwards compatible. So somebody on a really old device can still run it. We'll just click finish. So I'm basically just accepting all the defaults here. I'm not changing anything. Now you'll notice Android Studio is starting a tool called Gradle. Gradle is the name of the Android build system. So it handles all our compilation. So when we're first starting and building the project, right, it's going to try to build it. Will take a little bit. Again, the more RAM in our machines, the better for running this stuff. We'll let this run. So we're done. Oops. Bring this down here a bit. So the project view is a little bit confusing. The way that Android Studio displays the project structure is not actually necessarily the same as what the project structure actually looks like on disk. So here under our main app folder, we've got these subfolders, manifest, Java. However, if we actually go into our directory on our OS, we actually have this structure. We've got build. So there's our outputs are here. Any support libraries here. And then inside of source, so Amrit, you just talked about unit testing. Well, it's already set up, right? We've already got our main project and a test environment set up. So if we go into main, you just see Java and res for resource. So Android Studio is showing it to us in a way that it makes sense from a development point of view, but it's not actually, doesn't actually store it this way on disk. Something to note. It also is set up by default. Notice it didn't close my old project. So by default, when you open a project or create a project, it actually leaves the previous window open. If I can close that one, I don't need it. Okay. And again, I'm signed into Android Studio with my Google account, which you don't need to do for now, but you will need to do eventually. We start working with Firebase and wanting to publish to the Play Store, we need to integrate our Google account into Android Studio. We don't have to do it right now. So let's have a look at what we get. First thing is manifests. So our Android manifest sets out a few global properties of the app. So Android will use XML documents. At some point in the future, this might change. We're still waiting for them to evolve this to JSON, but for now, they're still using XML. So it sets up things like a launcher icon. So that's going to be the icon that actually displays on the mobile OS. Right? Users see that icon and tap. The label, so again, that's going to be the name of the application. And it sets up our main activity and also says that this main activity inside here, we have these intents. We'll talk a bit more about them over the next few weeks. But the important thing to note is that this main activity that we've created, it's not only our main, our primary activity, but it's also our launcher activity, meaning this is the activity that loads by default whenever the app is started. So we can override this stuff. We'll change it later on. This stuff just gets here set by default. Our source code is obviously in the Java folder. And again, we have test project here set up already. So inside, here's our code, auto-generated code for our main activity. So notice it's packaged with the package name that we set up. So the name of our package and the name of our project. Okay, so again, for your group project, this will be your group name in here. We've got a bunch of import statements. Basically, because I chose backwards compatibility, it brings in the app compat, so it allows us to run on older devices. And then it just has the default generic OS bundle. So we've got a public class that's a child of our app activity. And we've got one method here, an onCreate, that basically instantiates an instance of our layout and sets our activity main, called set content view. Well, that does what you would imagine. It actually says render this particular screen in the app. So all of our Java code later on, if we write Kotlin, it's all going to go in here. Every screen we create is going to have at least one Java class behind it. Some of them are going to have multiples. So for example, we picked the empty activity. If we had picked the basic activity, it actually creates it creates a main activity that's like a main container with the nav bar, but then we actually have a content main as a separate kind of sub activity. So depending on the template we pick, one activity, what looks like a single activity may be broken into multiple classes or components. In the resource area, by default, we get these. Drawable is going to be what you imagine. So static assets, like images, are going to wind up in the drawable folder. So we've actually got a background launcher. So this is our standard default Android icon. But if we open it up, we actually get it as an XML document. It will render as an actual PNG file, but it's actually created as an XML document. So we've got two different ways. We'll probably get into this next week working with images. We can either create images as XML documents, or we can actually create our own PNG or JPEGs and they'll render. We can do both. One of the nice things about using XML is they're scalable to different device sizes and resolutions in the way that SVG graphics would work in a browser. The layout folder, this contains the actual front-end screens. So our activity main, we've got the Java class here, and here, so basically this is the back end. And here's the front end. It's activity main, it's an XML document, and we've got two views. So this is the front end kind of design editor. It gives us a hello world label. It's got the name of our project here. And then we have two views. We have both a design view, kind of a what you see is what you get, sort of. What you see is what you get. We also have a text view, okay, where we've got an XML representation. So we can modify the design in either way. We can put components on in the design view by dragging them from the palette. We can drag things on. Or we can actually create, modify objects within the UI, within the HTML view. A lot of time, we're actually going to do both. John? No, automatically. So let's try it. Go grab a button, drag it somewhere in the UI. Got a little guideline here that tells me it's centered, left to right. Right? So it now gives properties here, so we can set things like change the text, color, etc. of the button. But notice, as soon as we jump into the XML, it's got a rendering here. If we want to do the same, we want to add something through the XML, it will render. So if I delete it from the XML, go back to design, it's gone. So you can use whichever you like. So all of our activities, they'll be in layout. That's where we manage the UI. The other important folder, we've got map. This is mostly, again, for setting up the launching icon. What you'll notice here, so notice there's it says we've got two different launcher icons, and one of them's got a 6. So if I expand that, you see all the different versions of that PNG. Again, those are all coming from this XML document. Why do you suppose we've got 6 versions here? Yeah, right? Different screen sizes, different resolutions. So we don't have to manually create all 6 of these versions. If we upload a new launcher icon, Android Studio will actually generate those 6 different versions of it for different sizes. The other folder we're going to work with a lot is values. So we've got 3 XML files here by default, and they're fairly self-explanatory. We can set up colors for the app. We also will put virtually any text content in our app in here. Instead of hard coding things like text on buttons or labels or instructions, we're actually going to put that content in strings.xml instead. Any idea why, Dan? Sorry? Okay, yep, absolutely. Can you explain that a bit more? How would that work? You got it. Rather than hard coding any text into the UI, if we put it in so by default we have a string, so we can make a subfolder. We want to offer our application in Korean. We can make a KR folder and have a kr/strings.xml with all our translated text in Korean, right? That way the app is easy to localize. So we will use this, and in fact, Android Studio is going to insist on this. It's actually going to give us a warning wherever we're hard coding text into the UI. It's going to tell us you should put this text in a string resource instead. Well, the colors, we're using hex values. Yeah, it's not language based. Yeah, that's right. Yes. There's also a style, so much like using CSS, we can set out a style and then apply that style globally, right? So if we want to have a whole bunch of, and by default, Android always gives us three styles: a primary color, a secondary color, and an accent color. And we'll look more at, we'll talk about material design and design palettes next week and how to implement those. So it's easy for us to style our app through here. There's another XML file we're probably going to wind up adding in here, which is called dimens.xml. That's for setting out dimensions. So for example, we want standard dimensions or padding around certain elements on all our screens. We can, rather than hard coding those dimension values in individual controls, we can put them in the dimensions XML file and just use the dimension name instead. That way, again, if we want to make a change, rather than changing, we decide all our text boxes that have a padding of 2, we want to make that 4. Rather than going to every text box in the app and changing it, we can just go to the dimensions file, change the padding there, so it's global. So we'll work a lot in these resource files, the layout. We won't be working drawable too much, but a little bit. Okay. And then down here inside of Gradle, this basically is just stuff. Most of this we're not going to touch. Most of this is just Android Studio plumbing for doing our compilation. The one file we will modify sometimes is this. Notice there's 2 different files called build.gradle. The first one we won't really use, but primarily we're going to use this file. So if we need to add dependencies, for example, or change versions of a dependency, all that's specified in the build.gradle. So next week we're going to work with the Android design repository, which is a separate component. It's not part of Android Studio, but it allows us to do things like use material design components. So when we add that, it's going to prompt us and say, hey, do you want to add a reference in the build.gradle file, which we'll accept in order to be able to use that library. Right? And again, I'm coming back, right? We've got JUnit referenced in the build.gradle, as well as a test runner called Espresso. So things are already set up if we want to do testing. So we will modify this a little bit. Again, let's say we run things and we find, so notice we've got 3 things set up related to the SDK version. What version are we targeting? What version are we compiling for? And what's our minimum? So I'm going to target 28, but I'm supporting back to 23. So if we find when we're developing that we need to target a different version, we can modify the build.gradle file. Generally, if you modify anything in here, we're going to get a little window popping up here, a little message saying once the build.gradle's been changed, we need to sync the project. Because now the build file is out of sync with the setup of the rest of the project. So it will ask us to do a sync, which we'll want to do. So that's kind of the main environment. So let's actually run the app in the emulator. So a couple of options here. This will compile. Make project, we'll use the Gradle system to build. This will actually run it. Now, if you have an Android device plugged in, it'll give you the option to run it on your device. We may have to do a little bit of setup with that. For now, I'm just going to run it within the Android Studio emulator. Actually, sorry, let me go back here for 1 second. The other thing we can see here, in design view, you can zoom in and out here. We can also, it's showing, so it's defaulting to a Nexus 4. It's saying this is what the app is going to look like on a Nexus 4, okay, on SDK API version 28. We can change these things. So if we want to see what's this going to look like, for example, at 1920, we can change it. It'll show us a preview mode. So you can play around with this a little bit. I had on the Nexus 4. I can also rotate it, right? So if I want to see what it's going to look like when the user turns their phone, I can just see that's what it's going to look like. So we can do some previewing even without running it in the emulator, although there's no guarantee that how it looks here is how it's actually going to run. So let's run it. Now it should hopefully show you, by default, a Nexus 5, but it may not. Does anybody have an empty? Okay. All right. So if that's the case, yeah, if you have no virtual devices, click on Create New Virtual Device. So you can pick any device. This one's fairly common, the Nexus 5X device. So you can just click on that. It may prompt, you may have to download the hardware profile. The support files to run this emulator may not be installed on your machine. So if it prompts you to download anything, just say yes and download. So notice it shows us the different screen resolutions as well as the density. Anybody have an idea what the DPI, what is the DPI? So the original, so this is 180 by 1910. We'll get into this a bit more when we start talking about font sizes, because when we're developing on Android, we don't ever want to actually specify things in pixels. The problem is if we specify them in raw pixels, right, on a different device size, those things don't resize. So what we're actually interested in is density independent pixels, right? The pixels, but related to the density or the screen resolution. So when we size things like fonts, it's going to be relative, the font size is going to be relative to the resolution of the device. So Android has a scaling mechanism that we're going to use for that. So once you're able to, are you able to create the Android virtual device? Is it still running or did it work? Installing? Okay. The other thing you can do, I would recommend checking off this box. Otherwise, every time we run it, it's going to ask you to pick a device. You check it off, it won't keep asking you what device do you want to use. Absolutely. I think every time you start the like when you open the project, like it's not forever and ever. Actually, I'll actually connect my phone as well, and we'll see if it shows up in the list of connected devices. I've already authorized my phone, which you may have to do. So I do recommend bringing a charging cable. If you have an Android device, you may as well bring a charging cable with you. If I plug the phone in, and it asked me, so it asked me on my phone, first of all, it gives me two permission screens, allow remote data, and now it's asking me to allow USB debugging. So I'm going to say yes and always allow for this machine. So now here's my, so I could actually run it straight on the phone if I want. It'll actually run faster that way. I'll keep my phone charged. Okay, so I can pick either one. So I'm going to run it on the emulator first. So it's going to build, so there'll be a little bit of a lag while it builds. So there's our Nexus 5. So we have these options, so I can do things like if I want to rotate the phone, right, I can rotate it. I can interact with the camera. It is slow. Notice it is running. The build is still running. The Gradle build is not fast. So when it finishes, it will load. If there's an error in the app, it will either not load at all, or we're just briefly going to get a pop-up saying the app has encountered an error. So here's what we get, right? So there's what it looks like. And then if I want to rotate the device, I rotate it. I actually want to rotate the screen, so I get this little button. There, right? So our little hello world label is centered, regardless of whether we're in portrait or landscape mode. So there's some, you can see these little guidelines. We'll talk about them shortly. These are called constraints. So those constraints help make sure that our items are positioned regardless of the orientation of the device. Drag this over here. Go back to Android Studio for a minute. Now, we've got a couple options. We can start and stop. Like we generally don't want to leave. On the one hand, leaving the emulator running, if your machine is pressed for RAM, it will mean Android Studio is slow. So you could stop it, but then you have to start it again each time you want to see it. The one benefit of leaving it running is now that it's running, we also have access to this button. If we stop and start, every time we restart, it's got to reload the entire application. If I make a change, I can click with the emulator running. I can click this button, and it will just apply those changes and not have to reload the whole app. So on the one hand, the emulator's running constantly, but on the other hand, the reloads are going to be faster. So you'll have to experiment with the workflow that works for you. So if I just want to go and change the text on my label, so it says hello world. So maybe I'll just take out the exclamation mark or change to say hello Android. Now if I just click apply changes, it does run the build again, but I don't have to start the emulator all over again. And it's not reloading, so it's quite a bit faster than if I actually stop and restart. So up to you how you want to try to do it. If you want to try it on your phone, or if everybody has a phone and wants to try my cable, you don't have a cable, I can give you this is a Samsung charger. You can try it. Yes, it is. Yeah, it should be faster running natively than on the device, than on the emulator. As I said earlier, in the past, the Genymotion emulator, which is a third-party emulator, it was much, much faster than the Android Studio emulator, but they've improved the Android Studio one. If you find it's really slow, you might want to try Genymotion and see if it's better. Okay. So I want to point out a couple of things about our UI. The first one is we actually have a warning here, even though we haven't done anything. This code was, other than me changing the text from the word world to Android, there's actually a warning. And what it's telling us is it doesn't like that we have hard-coded the text on this object, saying the hard-coded string hello Android should use a string resource instead. Now, some of the terminology for the UI components is different in Android than in what we're used to. Normally, in most IDEs, most frameworks, this would be called, I would think of this as a label, right? It's static text that's displayed in the UI, right? It's not something user interacts with. Android has its own names for things. Android actually calls what we would commonly refer to as a label. It calls these things text views. Which to me would seem to indicate something user would enter text in, but they have a different name for this if we look. So they have a text view, but then Android also has what they like to call an edit text. So that's what we would typically think of as a text input box. In the Android world, that's called an edit text. So all of the controls, all of the objects we can place in the UI, in the Android world, each of these things are known as views. We typically, in most architectures, we think of a view as an entire screen or layout. But if we have each button, each object in the Android world, those things are referred to as views. So if we want to deal with this, if I click on this text view, we can do it one of two ways. I can either go in the design view, I can go through the properties sheet. And instead here, I'm going to show you two ways of doing it. One is to add a new resource. So I just went in where the text is hard-coded, click the ellipsis here. And if I click add a new resource, we want to create a new string resource. So it's just creating a new XML node in strings.xml. So we could call it call the resource name. We are all in lowercase with underscores. This is one way I can do it. Provide the resource value that I want to appear on the text view and give it a name. Your resource names cannot have spaces, and they should be all lowercase with underscores. Kind of odd we use different naming conventions. This is the naming convention in the XML resource files. And in our Java code, as typically we do in Java, obviously we're going to name things, use camel case. So if I click OK here, right, our warning goes away. So our text now says @string, meaning in the string resources XML, with the resource called Hello Android. In the text view, it looks like this. If I go to strings, here's our resource. Our name is Hello Android, and there's our text. Yeah? Yes. Yes, so you could name it whatever you like. So if we want to change it to a different one, so I showed you how to do it through the designer, right? You just use the property sheet in the ellipsis, click that add new string resource. Let's add a second text view on here. Right away, every view absolutely requires these properties: the layout height and layout width. You'll notice in our text view, those were set to wrap content. And we basically got three options here: match parent, wrap content, or some other Android property. What do you suppose match parent means, and what does wrap content mean?
Match parent stretches it all the way.
Close. Kevin? Right. If the parent, so Sean, you're part of the right. If the parent stretches all the way to the edges, then this view also stretches to the edges. That's right. It inherits, as Kevin said, it's inheriting the width or height property from the parent. So if it's in a container, that's the width of the screen. This view will also be the width of the screen. So what would wrap content be by contrast? What would that do? It would be whatever the content, it would be no wider than the content of that view. So if the content of the view is 1 character, it's going to be about 1 character plus a border. Right? If it's 10 characters, it's going to resize to fit the content. In a way, yes. Now we also have the ability, if we want to set out a specific dimension, that's where we would use this Android, and then we're going to get into those dimension files where we can use density of pixels. It depends on the height as well, right? If we set the height, if we want it to wrap and fill, typically we can actually set the width. We can set it to 0 dp density pixels. Then it will adjust automatically. So we'll just for now put in wrap content for both. Let's set the text property. So there's a shortcut. If you're used to working with JetBrains products, lots of keyboard shortcuts. So the shortcut to create a new resource here, if I hit Alt-Enter, I get this little window, extract string resource. And then I get the same little context. little pop-up where I can create a new string resource here. Yeah. Are there any other Mac users besides Thomas? No. So we can create a second string. I'll just call this second string. Give it any resource name, any value. And again, we'll create it inside of strings.xml. So in Android Studio, there's a whole bunch of ways of doing this. If you wanted to, you could go to strings.xml first, manually create a new XML node here, and then reference it in either the property sheet in design view or in the XML view of your activity with @string/resource name. Whatever workflow is best. Typically, I've found this one is usually the most efficient. All I have to do is start typing text. It brings up the property equals, hit Alt-Enter, and then it lets me create the new string resource. The other thing we can do is if I'd hard-coded it, I want to move this. Here it gives me the warning that we got in design view. Again, I can just do Alt-Enter. And I can extract the string resource that way. Alt-Enter is also really helpful when we're writing our Java code. Whenever we make a reference, whenever we write code and that requires a new import statement, Alt-Enter will bring up the prompt making a suggestion as to what namespace or what package we want to add. If we accept that, it'll automatically write the import statement at the top of our class for us. Okay, so let's go back to design view now. So notice where our second text view appears. Why is it appearing there? So if you compare the XML of the first text view versus the second, you'll see a difference. We can also visually see in the designer differences. Will, what's different? Right. Now, constraint layout is fairly new. So we should give us a minute to talk about constraint layout. You'll notice that we actually, by default, get a constraint layout. Constraint layout's fairly new. This is why if you look at Android resources that are even, say, 2 years old, they probably won't say anything about constraint layout. So constraint layout, basically, Android, they stole this from Apple because Apple has been using constraint layouts in iOS development for quite a while now. Anybody want to guess what is constraint layout? I mean, if we run this, here actually I can just apply the changes because my emulator is still running. Maybe I'll shift it back to portrait. So when I apply the changes, we'll just see it flicker and restart. So what do you suppose those constraints do if you look at the positioning of the Hello Android label versus the Hello Android text view? Will? Right, so constraint, it's anchoring this both horizontally and vertically, and we saw even when I rotated the device, it stayed in the middle. Whereas this one is not constrained, so it just appears right at the top. So before we had constraint layout, there were a few other popular layouts. They still exist and we can still use them, but basically Android has moved towards using everything in constraint layout. So before, there are other layouts. There's a relative layout. There's a linear layout. Those are the main two. So if you look at Android tutorials, even a few years old, then you'll see those layouts. You won't see constraint layout. what do you think the benefit of constraint layout is? Kevin? Exactly, right? So that basically the idea of constraint layout, because we're working on different devices, different screen orientations, different resolutions, the idea is we want to maintain some kind of uniformity so that our app looks as close as possible to being the same. So basically what constraint layout allows us to do is anchor elements relative to all the other elements. Relative layout was kind of a first iteration. Okay? It was somewhat similar, but there was less functionality to relative layout than constraint layout has. So constraint layout is the default. We didn't put it here, right? We just created the empty activity, and this is what we got. So notice our constraint layout also has a layout height and width. So notice where our 4 constraints are here. So our bottom, we've basically constrained our text view equally in all 4 directions. Right? So it's equidistant from the top and bottom as well as the left and right. So not only can we position things relative to their containers, but we can position things relative to each other. So how would we, and we can do this either visually or in XML. So what could we do to move our second text view so that it appears below the first text view? Typing bottom. So we want the layout constraint, the top to the bottom of. Right, now the one other thing we haven't done is we haven't given IDs to these views. So I'll just hit escape and we'll come back to this. We need to give these IDs, text views IDs. So we'll call this one ID. And all the IDs here are prefixed, as you can see, with @+ID. So I'll just hit enter. So I'll just call this load text view. I don't love this naming convention for views, but this is typically how Android developers name the views in their activities. So a descriptive name and then the type of view it is. If you want to use a different naming convention, by all means. So I'll call this one the hello text view. We'll give this one an ID of, let's call this second text view. So now if we want to position the second text view underneath, now we can just reference, we get the code hinting popping up. So this control's top will be to the bottom. Now if we go back to design view, the second text view should be moved down. Yep. Right, we can do it right here. So it's now the top does not appear until the vertical end of the first text view. Now, what could we do to move this? And you can actually see the guideline. There is a little arrow here that shows the top of this. You can actually create the constraints visually by clicking on one side of a view and dragging to the side of another view. Or you can delete the constraints. You click the constraint and press delete. It will remove that constraint. So for example, if I go back to design and I click on this bottom constraint here, Actually, let's see. So if I click, I can delete that, which would actually shift that view up to the top now. It's no longer anchored to the bottom if I do that. So what would we do to actually center our second text view? Well, challenge is we could do right and left, but keep in mind they're different widths. So if we align the lefts, we can't align both the lefts and rights the way they are right now. Right. Yes, to the parent. So again, we could copy these two constraints. We copy the left and right constraints from our first text view. You just said correctly the first time. I repeated you wrong. So this will also put a left and a right constraint, which will center this horizontally. So now it's moved over. If I want to apply the changes in my emulator, this text view should now get moved down here. It does.
So you remove the bottom constraint, it will force it to the top.
Let's try it. So I'll click on my view. Oops. Delete the wrong thing. Oh, deleted all the constraints. I don't want that. As soon as I delete the bottom, it's no longer constrained. So if we wanted to center something, we would need all four constraints: top, bottom, left, and right. So without the bottom constraint, we have one on the top, but there's nothing pulling it down to the bottom. So if we're going to center something, either vertically, horizontally, or both, we want the constraints on both sides, or top, bottom, vertically. Our constraint back. There is one warning with constraint layout. What you see in the preview is not always how things will look on the device. So it's pretty good, but sometimes things are not going to be exactly where we think they are going to be based on this. Okay. So this doing the constraints visually at times can be a bit misleading, and sometimes it's almost easier to just go in and handle them logically in the XML to make sure things are positioned where we want to position them. Basically, the other thing about, you asked about relative layout. Relative layout basically positions everything relative to the container. It's not all views are relative to each other. They're basically, the views are relative to the surrounding container. Whereas constraint is any combination of the surrounding container and other views within the interface. So we have more options, right? We want to align a row of buttons, for example. We can put one button on and then make sure the tops of the buttons all align. If we rotate the device, those still stay in alignment, for example. It's not so much the strength, but there's a gravity property that does have weighting. So for example, if we wanted to have two sections of the screen, two different background colors, one that takes 1/3 of the width and one that takes 2/3. We can set an overall weight to 3, and then we can give each section a gravity. So one could have a gravity of, if we have this, we want this to be blue and this to be red. This would have a gravity of 1, that would have a gravity of 2. So even if we rotated the device, it's still going to appear that way. So we'll use gravity for weighting some way. The other thing that it's possible to do with constraints is you could set constraints that are in violation of each other. Right? If I set both the left and the right to the same spot, well, obviously it's going to throw errors if we do that. So it will take a little while to get used to because this is a relatively new thing for us. We haven't really worked with UIs where the elements are relative to either the container or other things in the UI. So there's a bit of a learning curve and some trial and error with this. That's fine. Okay, so we've looked at the string resource. I want to show you, I wanted to talk about the text sizes. So let's say we want to make this bigger. So if we go to our text size property of our Hello Android, so there's 2 different scales we use. We could size things in pixels. Again, this is a really bad idea on mobile devices because if they're on pixels, basically the size doesn't scale. So there's 2 different dimensions that we use in Android. There's DP and SP. DP stands for density independent pixels, and we use DP for text sizes. Okay? Here's basically the way this works. 1 DP is equivalent to 1 pixel on a screen that has a DPI of 160. So there's a scaling factor. If we set a text size as 1 DP, viewed on a device that was, say, 240 pixels, it scales it to 1.5 times. So I would say roughly, if we're looking at this, right now there is no text size. So notice it says the default is 14, but notice, sorry, DP is used for sizing objects. So we want to set the size of a border, a margin, a button, an image. We'll do all those things in DP, density independent pixels. The only thing we won't use DP for in Android are text sizes. Here we're using SP, which is scale independent pixels. And the reason is that scale independent pixels, they scale both for the device resolution, but it also scales for the user's preferred font size, right? So someone who has set their device to use a larger font, if we set font sizes in DP, it only is based on their screen resolution. Whereas the SP will also factor in the user's font preferences. So SP for text, DP for everything else. Pixels we're not going to use at all. So here's 14, here's the default. So we could set this, if I want to make this bigger, I could set it, and it would run. It runs. So text sizes we can set, but typically if we want to set dimensions on things, like let's say we want to set a margin or padding, we could do it here in DP. Let's just put in, I don't know, 10 DP. That'll give us some padding. It's not generally advisable to hard code those things. We can, but if we want to apply this style elsewhere, we could actually create it as a string resource. I'm going to take this out. I'm going to make a new resource. And notice here it's a dimension, so rather than asking me for a string resource, it's asking me for a dimension resource. So I'll call this large text. I'll give that a value of 10 dp. So then we can change this globally. We can apply this in multiple places. Instead of hard coding that number 10 into various text views, we can refer to the dimension resource instead. Functionally at runtime, they're equivalent, but from a maintainability and a scalability perspective, using those dimension resources is advisable. So I'll create that resource in dimens. So that file wasn't here before, but it actually generates the dimensions file. Right? So if we want to have like a main label on every screen and we want to set up styling, margin, width, padding, we could create a dimension for that, almost like a class definition in CSS. Then we can just apply that dimension wherever we need to. So in dimens, these are individual values, and in styles, these are aggregates of UI definitions. Right? So if we want to set up font, face, and color, and size, and dimension as a style, much like, again, we would do in a CSS file, this is in effect our Android equivalent in the styles file. So we will use those resources. One of the other things that we might do with the resource files is maybe we have a certain activity. It might not even be our whole app, but maybe a certain screen, certain activity within the application that will only display in landscape mode. Maybe in portrait, we just can't render what we need to. So we can create a separate layout that's landscape only for just that one activity. And we can in effect force it. So, or we may have within a layout, we may have multiple versions. So we may have kind of a scalable version for phone, but then we might have, for example, a separate version for tablet. So for example, on a phone, a common thing might be, we have a slide out menu. When you want a menu, you click on the menu slides out. Whereas on a tablet, we have the real estate where we can have the menu displayed at all times on the side of the screen with the main panel. So it's basically the same activity will have the same Java code behind it, right? But we may have two different versions of the layout. One that swaps and scales and one that's perhaps tablet only. So we've got the ability to do this. So you can just we can just poke around here, right? So we can drag other things on. It has templates for things like password boxes, phone, email. So it will automatically validate for those kinds of things. We'll use this probably next week. This text input layout, that's kind of for laying out forms. So that we can, almost like an HTML field set, we can set out a block for each area of the form. We'll use that. Different buttons. This floating action button, that was in that basic activity we saw when we first loaded. We want to enable browser video, for example. If we do want to use a different layout other than a constraint layout, we can replace the constraint layout that gets added by default now with a table, frame, a linear layout. But again, constraint's going to be the default. We have some different containers, right? So different ways of laying things out, buttons, tabs, tables. The scroll views, we're going to use these. The recycler view, we're going to use. The recycler view basically allows us to display a list that can be updated in real time, right? So if we're displaying a list from a database, we change the data source, that recycler view can just requery or redisplay. Some other, if you want Google Ads or Maps, we can just bring a view right in there for that, built in, as well as we have an old style. So most of these other containers, they're in legacy. So you can use them like a grid layout, a list layout, a relative layout, but they're old. The constraint layout has pretty much replaced this stuff. Okay. Anybody have, that was most of kind of what I wanted to just get our feet wet with today. Questions? Okay, I'm going to leave you with a little bit of homework. Just for practice. Again, you guys, you're in third year, so you all know by now, the more you work with the stuff, the better you get at it, right? The more familiar you get at it. You know, if you only look at it Friday mornings from 8 to 11, and then when you're working on your assignment, you're not going to be nearly as confident with the technology as you probably want to be by, you know, the time April rolls around. So here's some things you can try. I'll just have to enable this. Okay. So two things you can try. I'm not marking you on them. If you don't want to do them, don't do them, but they're good practice. One, find an app either you already use or one in the Play Store. See if you can mimic the main screen. Create a layout and see if you can copy it. Just to get used to playing around with the different types of views, how constraint layout works, how we size things. Okay. Use the resource file, like use the resources for dimensions, colors, play around with it. The colors you can set up inside of, we can go into colors.xml. So if I want to change this, right, the primary color, we'll change this to something else. Play around and see if you can mimic one screen, just the UI part of it. That's one thing you can try. So if I change the color in here, right, the primary color, which is used here, is different. Other thing you can try and create a business card as an Android app. Put in your contact info, size things appropriately, move them around, create a logo, even create a business card for your group if you want, just to get used to the layout. Okay. So again, I'm not marking you on it, but just something you can do in terms of practice. So what we'll do next week, it'll also give you a chance to play around a little bit with the image view. We'll work with the image view more next week. So we're going to look at, again, a little bit more about constraint layout, again, constraining things together, sizing things, making sure that we can position things and get our app to look the way we want. We'll look at how do we display an image, how do we scale it, how do we change an image, and also we'll look at interacting with, instead of creating an empty activity next week, we'll create a template with a basic activity. It gives us that little floating action button at the bottom. We'll look at moving that around, restyling it, and then how do we write some Java so when we click that button, something actually happens. So we'll kind of do that stuff next week. As well, I'll send out an announcement, but there should be some people here in class next week to tell us more about the project. Okay, so I will stop my video stream. There's not much here, but there's no harm. I will push this stuff up to get right from the terminal here. So I will do that. Okay. Other than that, have a good week. We'll see you guys next Friday.